Alright, so now that we've created a merge to merge all our outer filaments, now it's time to create some other ones. And we're just going to double check on these to make sure they're being passed through the net correctly. I don't trust things anymore. When things go wrong in VFX, they usually go very wrong. So I've added a null and changed it to yellow, and that's just going to be out for our outer filaments. Some of them still go through our shape, which is pretty cool. That's what I want. So over here you can see that I've added 2 new setups. Let's follow this path down here because this is feeding into our filaments that we set up in the above setup. So over here I've added a point VOP. I've played around with a ramp just to mimic it like that. It's really up to you. There's a width multiplier right here. And what this whole pop VOP is doing, it's not a pop VOP, it's a point VOP. What it's doing is just amplifying the p-scale, or the width as it were. So width, I'm just going to put a width there so you guys can see that. If you go inside of it, it's not using the regular geometry global VOP, but instead it's picking up an attribute called cost, ramping it up, and multiplying it. And we've promoted the parameter input 2 to the top, and then we've just renamed it through the parameter interface, which I'll show you in a second, to width. And then this is a bind export, and exporting our parameter, which is width, outwards. So if you go up to the surface, the ramp should be promoted automatically, so don't worry about that. If we go to the width multiplier and we want to rename it, which is coming from a multiplier, that's where you can find it. And so down here at our polywire, what this is doing is it's playing with the wire radius. So basically it's adding the width that we just made, so the parameter, and then it's just adding 0.012 to it. So it's just taking a default setting of 0.012 as the width of the polywire, and then it's just adding the width that we set up earlier into that whole setup. Down here is a merge, and you can see all of a sudden it gets a little bit more wild, and that's okay. We've merged our different setup, which we'll go through in a second over here, and then we've added a null that says out filaments. So if we go over here, we once again have a merge, and what this is doing is merging our out filaments over here and our geometry up here. And unfortunately I had to go up here and I had to add a tetrahedralize because I found out that we do need it. So just be aware of that. I did have to file cache this back out again, but yes, you do need to re-add it into your setup. My bad. So if you go back down here to our merge, this is merging all that together, and we've got 2 different kind of filament outputs, and we can add nulls there if we want, but in this case I didn't really want to. So our start points, and this is very important, you need to, instead of just adding a number into here, what you kind of have to do is select one by clicking this arrow, going here, clicking somewhere on your shape, or somewhere on the filament inside of it, so you could dive inside and click a, filament number, because this is tracing the outside of the sphere. Probably good. You could grab a point there, and you can just press enter, and it should re-add that to the base group, whichever you prefer. Our end group is once again a group by range. We've named end, switched over to points, and then added a select range of 1 to 789. And then finding the shortest path, we should see something up here, which is this very kind of jaggedy kind of pathways, which is kind of cool. For the start over here, same concept. Go in, click this, select your points, click enter on your keyboard. Group by range. This one's a little bit different. So it's 4, 5, 6. And then find shortest path group, which is these ones. And these are merged together, so we have some overarching kind of things. And then we've added a point VOP, which is just a copy and paste of this point VOP over here. And I'll colorize them just so you guys don't get confused. And because they're really just copy and paste, The only thing I've really changed on this one is the ramp. And also the width is 0.01. The poly wire has a lower radius. So basically it's the width again that we made in our point pop plus 0.015. And that is going out to our filaments in this little null. And then they are merged together into this little bundle over here that looks very wild at this point. But in a second, we'll get to our VDBs and I'll show you how to do that. But before we do anything first, we're going to go to our controller and we're going to dive inside and add some more values. So for our big filaments and our additional filaments, what we need to do underneath this folder is go to our ramp. And of course we need to forbid linking. Ramp width. And just change that there. And then we'll go to polywire. We'll put that in here. Wire radius. Or we could go, you know, width radius would probably be more accurate, I think. And we can apply and accept for that. And you may notice at this point in time in the simulation, this is when Houdini likes to do a lot of thinking, so don't get too scared by it. We'll just let it think it out. Awesome. So the other thing we're actually going to add to our parameter interface is we're going to forbid linking again. And we're going to go over here and we're going to create a new folder that says out inner filaments. I'm going to go here. There we go. And I'm just going to steal this. And we're going to once again promote our ramp into there. Put that in the folder. Go to our polywire, put that in there. And then what we're going to do next is put in our start groups. Actually, we'll pause on the start groups and just put the end groups for now, because I think if we play around with our start groups too much, we might run into issues. So this is going to be end points. And then this one, I'm going to put in there. So end points additional. And we'll just rearrange these so they're much cleaner. And we'll hit apply, and then we'll hit accept. One thing I do want to add into our setup is the file cache. So I want to take the save to disk parameter and just put it at the bottom of our start geometry, because why not? Save to disk, and we're going to need that later, so I'm going to put that in there. And we'll hit accept. And alright, we have our filaments. Before we do anything else, I'm going to also add another cache node down here. And we're going to cache out our filaments. 1, 2, 3, go. Alright, so you can see that I've jumped ahead. and I've built some convert to VDBs. So basically what we're going to do, now that we've cached out our filaments, is convert them to VDBs. So we've quickly laid down a convert to polygons, just to make sure that what we're dealing with are polygons. Otherwise, things can go wrong pretty fast. I've laid down a VDB from polygons, and what this does, it looks a little bit awful actually, because of how, you know, blocky the VDBs are, but in a second you'll see that everything is actually fine. We've reshaped the VDBs, so they look really thick, and the offset is 0.8, and then we've taken a reshaped VDB, and we've eroded it by 0.21, and then we've converted it to polygons again, and as you can see, now we can see these clumping starting to affect the overall shape of our web. And we can see that our shapes have actually started to merge with one another, and you can see they're quite thick. I would actually even say we could probably smooth them out. So before anything happens, before we get settled on anything, let's see if we can up-res this just a little bit. Or what happens when we up-res it. You get thicker lines. And I would like the thickness right now. We don't want to make them too thin, because when we convert this to a volume later, we can run into several issues with how Houdini handles the thickness of the polygons when it's generating a volume from them. So I like this, I like what we've done, and what we can do now is file cache this out and save it to disk. So as that's in the process of doing that, you can see that I've added another null that says up to VDBs. And what we're going to do next is we're going to add these parameters onto our little controller. And that's pretty awesome. So let's go up to our controller, and we will edit parameter interface, and we'll close up our little, and we'll do this folder name as VDBs. And we don't need to add the convert onto there, but we should add, I think we should jump up to the filaments, and just add the save to disk into our inner filaments. And as you can see, we need to turn that off. So add that there. And so we don't need to add the convert. We should add the VDB from polygons in case we want this finer. So add that to this. Voxel size. And the reshape. We'll add the offset in there. For whatever reason, it doesn't want to automatically drop it underneath my folder. We'll name this dilate so we can differentiate what it is. And then we can go to road and do the same here. We shouldn't have to change anything on our convert, but we do need to add our save to disk, because why not? And we can apply, and we can accept. And there we go. We have the VDBs set up, and they should all be underneath our controller on VDBs. Alright, so now that we have jumped ahead a little bit, you can see that I've created some outputs for our nodes, and we'll get into them in just a second. So you can see our black outputs are all labeled in black, so we know what they are. So let's dive in and see what we've done. So for VDBs, I'm going to change my background to a dark gray so you can see the cosmic web. And you can see we've got a pretty great shape going. I think now is the time that I'm going to add a camera. You won't be able to see it from the top here, but I'm gonna add a camera simulation V1. And we'll come back to that later. So we'll dive back inside. And you can see that I've set the voxel size to 0.012 and turned it from a distance VDB to a fog VDB. So it's picking up our density. And now I've added a null down here that says out web, and what this is just going to output our main web structure, which is this. And then we have a bounding box over here. And what this is, and I'll just put this name, is just kind of the casing of our simulation. So if we jump up here, we can see that in this simulation we see a box, right? In most of them there's a box. So this is basically what it is. It's optional, and it's for if we need it. So you can see it's generating a box. There's not any lower or upper padding, but it's creating bounds when empty, and that's pretty much all we need. It's creating a box. I've then put a wire down, and what this is doing is just picking up the edges of our bounding box, and the wire radius is 0.004. And then I've made sure the normals are correct because we need to render this. And then I've added an outbounding box. I'm just going to go like that. And we've got a null. All this is doing is just merging this together to make sure our bounding box is fitting inside our simulation, so we can see it there. If we jump over here, you can see that these are a different mesh of things, and what this is something I'll explain right now. If we look at different simulations of the cosmic web, we can see that there's different densities, and these densities are visualized through different colors. And so what we're going to do is create these little yellow and purple and blue densities that we can see over here. So let's jump into it. So the first thing I wanted to do was convert VDBs from all of them. So what this is doing is just converting this to a fog to SDF from our main node here. And all of these are pretty much the same. So if we jump to different ones, these are all the same. And I'll color code them so you know they are all the same. You can just copy and paste them. Then the next thing we are going to do is, you can see for this one, I've eroded the density a little bit, so the offset is 0.14. And then I've converted this back to fog. And then I've cached this out, and we'll cache it out right now. So looking at our convert VDB, I just realized while we were caching out that these are probably way too small, and we need to up the density just a little bit. So I'm going to go up to my reshape SDF and probably turn this down to like a 2. I want to be able to see my densities a lot more, and here we can barely kind of see them. So we'll probably wrote that down to a 1 as well. You go higher, maybe. Let's crank down the ISO value. I'm going to put this at a 3. Let Houdini think herself out. Someone, we have a better pattern there, right? It's not just me. Awesome. So now we can cache that out. Convert that to VDB, and we'll cache it out. Alright, so that is finished caching. And down here I've added a color stop, and you can see it's purple. So what this purple thing is going to do is, if we jump back here, you can see purple backgrounds. Pretty simple. I've added a null that basically says out close-up infra 1, and then there's 2 others. So the next thing to do is to make sure these ones over here are working. So if you look over here, we've kind of got less than I would like. So we're probably going to push this down to a 4 and let Houdini think herself out. And then we'll file cache this out. Now that it's done, I think too much erosion there. We jump over here, It should somewhat match the other one. Yeah, we want a little bit more. That looks good for now. We'll save and then cache this out. All right, so now that that's finished cooking out, we can look at the color. And the color here, we have a pinky color. So it's a class group of points, and it's placed down here. And we have our output null. So if we jump over here, we should make sure this one's a little bit smaller than our other one. And we'll save, because VDBs can make us go a little bit haywire. I'm going to turn this down from a 1, maybe to a 1 this time, just so we can see something. There we go. Just a little bit, and then we'll save that to disk. Alright, so now that this is finished cooking, you can see that we are down to our last 2 nodes in this round, and that our output color is this blue, and we have our output null. So the next thing we can explain is the stars. In some of the setups here, you can kind of see these star clusters where these dots are, and I wanted to add more variation in this setup, so I made stars, if you want to put that in quotations. Down here, I wanted to scatter the stars where the clumps are. So it's sampling the convert VDB over here. Let Houdini think there, but I think I'm going to attach that to the file cache to make it less, heavy. So we have our scattering points, and then we have our generalized points, which are on our web over here. And I think I'm going to reduce the amount of points, maybe by 1,000 here. Might be a little bit of overkill, but if we turn down our point size, we should see them. And all these are scatters, and this is sampling the web up here. These are merged together to form starry webs. And then I've had a VDB from particles, so you can see that these are clumped together. And the point radius scale is 0.02, and the voxel size is the voxel size is 0.004. And I've added a VDB smooth to help these kind of clump together. And then converted these to polygons. And then added another VDB from polygons, except for this time, it is sampling the polygons and creating a density. So it is a voxel size of 0.008 and a fog VDB of density. Down here we've done something a little bit sneaky. So as you know, our billowy shader samples the attribute temperature from any density it is, colorizing and visualizing in Houdini. So I've created an attribute called temperature, and what this is for is to just increase the temperature and emission of our stars. So you can see them in the web there. Kind of cool. And the value is currently 0.7. And this is a class point attribute and a type of a float. I've colored them this gray color, and then just put an out star secondary down here. And that's pretty much it for that. The merge down here we've explained earlier, and right now I'm going to proceduralize this and add these to our webs. So let's open up our parameter interface and add some stuff to it. So we're going to add a folder. We're going to put web, and we're going to do VDB from polygons. So we're going to put the voxel size in there, and of course we've got to change that. Voxel size, so I'm going to put final voxel size because that's pretty much what it is. And then we're going to go over to our bounding box. Put the folder under here. So it's on bounding. Whoops. And then we're going to add our bounds. So I'm going to add our minimum lower. Go in there lower. And upper padding. And our wire radius, which is 0.004. Put in there a wire radius box. And then our normal will be fine with that. So we'll hit apply for now so Houdini can think that over. I find doing this in steps helps Houdini from crashing mid parameter interface change. I know it's a little bit slower, but I'd rather have this happen than my entire file crash. So we'll save. Then we'll go over to our scatters, so our stars. We'll do this, and we'll go stars. And we'll do the total force count. So these will probably be counted as total points web, because these are generated from the web. And then these ones are kind of like the total point clusters. Because they are clustered in the points are clustered together from those voxels. So the VDBs, because this is quite different from our points, I'm just going to add a separator to separate that on our interface. The point radius scale, we're going to probably need that if you want your bigger stars or your smaller stars. So you'll see in the final render where they are. I'll point them out. So we're going to go star radius. That's pretty much what it is. And then the voxel size, stars. VDB smooth, we're not going to change too much on there. VDB from polygons, so the voxel size, I'm going to call final. I'm going to add another separator in between those ones. Find this one, voxel size final, because it's the final voxel change. And then the attribute, we're going to go temperature value. So put that down there. And then we're going to put our color, because why not? There we go. So the next thing we're going to do is we're going to create these close-up infra things. So the infrared color. And I'm not going to put that underneath our web folder. I think I'm going to do that in a separate folder because they are a separate function of our creation. So infrared coloring. There we go. So if we go in here, the first thing I'm going to do is add a different folder that says outer coloring. Mid coloring. And inner coloring. And so what we're going to do next is, because we edited the convert VDB on this, we might need the values. So we're going to let Houdini think that out. Before anything happens, I'm going to save. I don't trust anything anymore. So for our outer coloring, we'll do the fog value. There you go. And the next thing we're going to do is add the reshape. So this is going to be a road that wants to go in there. We'll go road value. And then for the end here, we'll probably add our color, as well as our save to disk, because why not? Sorry if you hear a fire truck in the background. I live in Toronto and things happen. So we'll add our save to disk here. And our color there. And just continue on and doing this for our inner coloring. And our file save to disk. And the final color. Perfect. And we'll apply and let Houdini think. And there we go. That's pretty awesome. So if we jump to the surface, now we can promote everything up here. And I'm going to quickly save before things get hectic. So we're going to render our web. And we're going to go into our big giant setup. So where's our simulation one? There we go. And if you've labeled all your controllers with capital letters, they should appear at the top so you can grab them easily. No, I don't want my controller web. I want out web. Probably that. So if we turn that on, we should see it. And if we look through our camera, we should see our web. So now we can go here. And you can notice that I've created another attribute, which is temperature. And that's going to give our little tiny infrared colors some more temperature when we put the shader on. So this one, I'm going to grab infrared 1. Turn that on so we can see it. Go in here, grab number 2. Turn that on. And you see I've added another attribute crate down here, which is value of 4. Add another one. Turn that on. Render our stars. Let's go find them. And then render our box, which should be in here as well. And there we go. Pretty great. So let's take a look through our camera view after we save to see what this kind of looks like. And there we go. Like, we can see that our voxels are very big on this one, so we can see a lot of the density start to take place. We can see the purple is very faint, but we have a lot of clustering. So the clustering is up to you and how you want to make it look like that. But overall, I think it's pretty good. I'm going to make 2 different changes. I think I'm going to reduce the density on our shader for the close-up infrared. So we're going to go jump over here. And probably make the smoke density like 0.5. Doesn't look too much like that. Our star clusterings are the bright red yellow things there. So that's cool, I guess. If we jump out, we can slowly edit everything to make it a little bit more vibrant. We could even add an emission attribute to our web itself, which I'm actually considering doing, just to make this a little bit brighter, and so we can see that purple color kind of pop. So we'll create an attribute called temperature. And there we go. We got a very, very bright red kind of web going, which is really cool. So you can adjust that how you see fit. But if you were trying to mimic something that was more infrared-y, this is how I would kind of approach the situation. But yeah, that's the first version of how you can create the cosmic web. And I hope you enjoyed that.